Arrays and linked lists are two of the most fundamental data structures in computer science. But do you know when to use which one? In this video, we'll break down the key differences with examples, visuals, and real-world use cases. Let's get started. What is an array? An array is a linear data structure where elements are stored in contiguous memory locations. Each element is accessed using an index, starting from 2000. What is a linked list? A linked list is a collection of nodes where each node contains two paths. Data and a reference, or pointer, to the next node. Unlike arrays, elements in a linked list are not stored at contiguous memory locations. Arrays use static memory allocation. You must define the size of the array at the time of its creation. Once declared, the size cannot be changed. Linked lists use dynamic memory allocation. You can add or remove elements at runtime without needing to declare a fixed size. Arrays support random access. This means you can directly access any element using its index in O(1) time. Linked lists support sequential access only. To access an element, you have to start from the head and traverse node by node until you reach the desired position. This takes O(n) time in the worst case. In arrays, inserting or deleting an element at a specific position requires shifting elements, which takes O(n) time. In linked lists, insertion and deletion are efficient, especially at the beginning or middle of the list. You simply update the pointers, which takes O(1) time if you already have the node reference. Arrays are memory efficient when fully utilized, as no extra memory is needed for pointers. Linked lists use more memory per element because each node stores an additional pointer to the next node. Arrays are cache-friendly. Since elements are stored continuously in memory, CPU caching makes access faster. Linked lists are not cache-friendly. Because nodes are scattered in memory, they can cause more cache misses. Let's talk about ease of implementation. Arrays are generally easier to implement and use, especially for beginners. Why? Because once you declare an array, you can directly access and manipulate its elements using simple index notation like array of size to equal to 50. In contrast, linked lists are slightly more complex. You need to create a node structure, handle pointers carefully, and manage memory dynamically, especially in languages like C or C++. For example, to insert a new node in a linked list, you have to allocate memory for the new node, set its data, link it to the correct node by updating pointers. If even one pointer is incorrectly assigned, it can cause errors like segmentation faults or memory leaks. So while linked lists offer flexibility, they require more attention to detail and debugging skills during implementation. Use arrays when you know the size of data in advance. You need fast access using indexes. Examples: storing marks of students, accessing game scores, matrices. Use linked lists when you expect frequent insertions or deletions. You don't know the size of data in advance. Examples: music playlists, undo-redo systems, memory management in operating systems. Arrays come into major types. One-dimensional arrays, which store data in a linear form like a simple list. Multi-dimensional arrays, like 2D arrays or matrices, where data is stored in rows and columns. Example: a 1D array, int type marks of size 5 is equal to 90, 85, 70, 95, 88. A 2D array, int type matrix of size 2, 3 is equal to 1, 2, 3, 4, 5, 6. Linked lists also come in different types. Singly linked list, each node points to the next node only. Doubly linked list, each node has two pointers, one to the next node and one to the previous. Circular linked list, the last node points back to the first node, forming a circle. So arrays are more about dimensions, while linked lists are more about structure and connectivity. Let's understand their structure with a simple example. Array representation: 10, 20, 30, 40. In memory, all elements are stored in a contiguous block, like this. Vertical bar 10, vertical bar 20, vertical bar 30, vertical bar 40, vertical bar. Each box is placed side by side in memory. Linked list representation: 10, 20, 30, 40 null. Each node has two paths, data and a pointer to the next node. The memory location of each node can be different and scattered, but the pointers keep them connected. This clearly shows arrays are tightly packed, but rigid. Linked lists are flexible, but loosely connected. To summarize, arrays offer fast access and are easy to implement, but are less flexible. Linked lists are more flexible in size and structure, but come at the cost of slower access and more memory usage. Now that you understand the difference between arrays and linked lists, try implementing both and test their performance. Don't forget to like, share, and subscribe for more computer science content.